Hello and welcome to the second part of the sub-series on implicit differentiation and its applications. So today I'll just be quickly showing you how to find the derivatives of inverse trigonometric functions, and that should apply to you if you're doing AP Calculus or A-level further maths. So by the definition of the inverse sine function, what it means is that if you assume that is y, then working out sine of y will give you x, which is the input. So using this expression over here, we're just going to use algebra and calculus. So basically how you'd normally do any implicit differentiation task. And the way we do it is we just apply derivative sign to both sides. So if I now find the derivative of this side, the right hand side of the left hand side, sorry for the mess, then we have cosine of y times the derivative dy over dx. And remember that just because we're working out a function of y rather than a function of x, which means it's a composite function because y is already defined as a function of x. So that means we need to use the chain rule. And then that is equal to 1. So then dy over dx, just by using simple algebra, using division of cosine of y from both sides. And that's what we have. And now, we don't really know what to do with this. This is basically it, but we don't know what cosine of y is. It's hard to define. What we do know is we know that in this case, we know that y equals sine, arc sine. You might see it as arc sine of x, but I prefer this notation because it takes less time to write. So then we also know that by this definition, x is equal to sine of y. And we have a trig identity. Sine squared of x plus cosine of x equals 1 at all times. It's an identity, not an equation. So then that means surely it's the same thing as 1 over the square root of 1 minus sine squared of of y, because it's with respect to y, it's in terms of y. So then this expression over here is very interesting, because we already know that sine of y is our x in this case. So then we can just simplify it or substitute it to this expression over here. So that's it. Because remember, the squared symbol here doesn't mean you do the function twice. It just means you're doing it and then getting the squared result. And that's a really important kind of common derivative if you want to get remembering the inverse trig functions and the derivatives. That's really useful. And now, as far as it goes for the derivative of inverse cosine of x, it's very similar, an incredibly similar procedure. We just assume the same things as we did in the last kind of exercise. So we use this knowledge that that cosine of y should get you back to x, because it's an inverse function. If you do the upright like a proper function of that result, you just go back to what you started with. So we know that, and we know that we can differentiate both sides. And that's a bit cheeky for me to write it like that, but so what is the derivative of cosine of y? And then, what is the derivative of x? And we know the derivative of x is just 1. So we know this is 1. And now, cosine of x differentiates to minus sine of x, but it's y, so I need to times it by dy over dx. Note that this is not the same thing as this. This is the derivative operator, whereas this is the derivative itself. So I'm just going to write minus 1. Okay. And then that is equal to 1. So then we can just kind of divide both sides by this, and we end up having dy over dx is equal to 1 over, or minus 1, because we are dividing by minus 1 sine of y. Now if I just kind of take it back, then we'll see that if we can apply the same trig identity as we did here, we end up having minus 1 over the square root of 1 minus cosine squared of y. Yeah. So yeah, if I haven't explained it already, the reason why I'm doing it this way is because we're trying to be kind of cheeky here and find another more useful expression for sine of y, because it has no application in this particular case. So by finding a way to rearrange it and find sine of something here, and it can be anything, it doesn't have to be x, then in this trig identity. So according to this, we're trying to find sine of y. And we do it many times in calculus, not necessarily because it makes sense, but because that way it works, and yeah, it just doesn't have a mistake. This is an identity, so it's always correct. So using it is correct, and then that's how we work it out. So this is the same thing as, because notice, here we have a squared version of what we're trying to work out. Or x, not what we're trying to work out as much as it's just a useful expression that we already encountered here. So it's kind of a deja vu from the first example, but just remember it's the same thing as 1 or negative 1 divided by the square root of 1 minus x squared. So here it's really similar to this. Now solving the inverse tan function is going to take a long time, and I'm afraid I don't have time to do this video, but I might do it later on in the series. But at the moment I'm planning on making a video on working out limits, because I feel I haven't quite explained things thoroughly in that kind of part of the series. It just had like 2 videos. And then hopefully when I'm done I'll do some videos on logarithmic differentiation, which is really useful. We felt that you just don't know through derivatives, which is the most important thing for you to remember in derivatives before you move on to integral calculus. So I'm going to leave it for the next video, and see ya.